Hello again. Now we have our next and I hope last meeting. And we are going to start with previous section presentation by Larysa, Savytska and Big Sources teams. Are you ready to start in?
Yes, I think we are ready.
Yes, please, we ask you. Yes, we see. Please.
Okay. So good day, dear participants of the conference. My name is Larysa Savytska. I'm associate professor from Simon Kharkov National University of Economics. So my co-authors here you can see at this slide. Today in my presentation, I'm going to speak about using word-to-vec technique to determine semantic and morphologic similarities in embedding words of the Ukrainian language. The next slide, please. The article deals with the word translation into vectors of real numbers, word embeddings, one of the most important topics in natural language processing. Word-to-vec is the latest techniques developed by Thomas Mikhailov to study high-quality vectors. The next slide, please. The research using machine technology, word-to-vec, is of great importance to computerize many areas of linguistic analysis. Linguistic analysis such as identifying semantic similarities of the words and phrases, automatic generation of thesaurus and bilingual dictionaries, and so on. The next slide, please. The majority of studies on clustering the word vectors were made in English. Turgut Sübay did research on the vectors obtained by using word-to-vec technique from the Turkish corpus, considering the meaning relations and formal features of the words. Dmitro Chaplinsky has already counted and published vectors for the Ukrainian language by using LexVec, word-to-vec, and GloVec techniques. It was a project to create corpus obtained from fiction, newsware, and urban texts. There is no research done on vectors obtained by using word-to-vec technique to create Ukrainian corpus obtained from Wikipedia dumped at the main source. The next slide, please. The open source Python programming language was used to obtain word-to-vec vectors with the word-to-vec techniques and to calculate the cosine similarities of the vectors. A resource containing open source licensed software libraries called Jensen were used. Continuous back of words algorithm is used for machine learning. The vector size is taken as a 300 and the window size as 10. The learning process is done in 5 epochs. The collection contains more than 261 million words. The dictionary of words, unique words obtained from the corpus in more than 709,000. Such a big data gives us an opportunity to conduct high-quality semantic and morphologic analysis on arithmetic operations. Clustering of the Ukrainian word vectors. Word vectors obtained with the word-to-vec over the general contact Ukrainian corpus are clustered and related in terms of the semantic relations of the Ukrainian words. Here, as you can see, as a result of training the word Kharkiv, the city name, the first 5 word vectors with the closest cosine similarity to the vector Kharkiv are shown below. The words Dnipro and Poltava represent the other city names in Ukrainian and belong to the lexical paradigm of the words related to the meaning of the word Kharkiv. Arithmetic operations of the word vectors and semantic relationship between words. New vectors can be obtained as a result of adding and subtracting arithmetic operation the words vectors obtained from the Ukrainian corpus. The cosine similarities of the vectors obtained by the process were examined in terms of their compatibility with the meaning of the process. The first example is similar to the English example shown by Thomas Mikhailov. The first 5 words vectors with the closest cosine similarity to the result vector of Korol minus Cholovik plus Shinka operation the first vector among the cosine-like vectors. The process and result vectors are compatible with the semantic relationships of the words they belong to. The next slide, please. So the next slide, here you can see the first 5 word vectors with the closest cosine similarity to the result vector of Anglia minus London plus Kiev operation as shown below. The result of this operation is Ukraine, the first vectors among the cosine-like vectors. It is the transition of the relationship between countries and cities of their capitals. Vectors are compatible with the semantic relations of the words they belong to. The next slide, please. Formal clustering of Ukrainian word vectors. Ukrainian is a language of inflection. Effectual morphemes in Ukraine are mainly suffixes and sometimes prefixes. When searching similar words by using word vectors, it is seen that words ending with the similar suffixes can be reached. The word vectors obtained from Ukrainian corpus with word to word are clustered and related according to the Ukrainian specific suffixes. The first word here you can see to be examined is the word Kholiev. The first 5 vectors, word vectors with the closest cosine similarity to vector Kholiev are shown below. So here you can see that the clustering of word vectors is related to the formal feature infinitive suffix "-th". The next slide, please. Arithmetic operations of the word vectors and formal relations between the words. The first 5 word vectors with the closest cosine similarity to the result vector of Kviti minus Kvitka plus Yabloko operation are shown below. According to these results, the first vector, Yabloko, clustered like a cosine, is a vector, belongs to the formal feature, plural form of nouns. The clustering of word vectors Runo, Pero, Teля, Porcha is related to the formal feature neutral gender. The next slide, please. So what we can conclude? That the research using machine word to word is a great importance to computerize many areas of linguistic analysis. The result obtained regarding to the clustering of the word vectors proved that there is an affinity in the construction of words in both semantic and morphological similarity. That indicates a high structural level of construction of the Ukrainian language. Thank you for your attention, patience, and interest listening to me. If you have any questions, please feel free to ask them.
Yes, I have a question.
Please, Elena.
I see you use a lot of number in our vectors. Could we use a fewer number, and what is mean of this number? Maybe we can use only 8 number, not 16.
Numbers, you mean that according when we are training the words? Of course, because for us, the most important, this is high quality vectors. That's why when we are doing the training, we use the mainly that we are going to use 10 numbers. Even here, I didn't show the numbers after that. Here you can see according to the frequency, what is, if we train, for example, the vector Kharkov, what is the closest vector? And after that, you can see the number, how is the closest. That's why it's the first place, the second place, the third place, and the fourth place, and so on. That's why we show the numbers from the training to prove you the results and to show the results how it was.
Thank you.
And I have a question too, if I can ask you. Do you research some specific area, some specific domain, or different like apple, float, it's lexes different?
Thank you very much for your question, because we are only at the beginning of our scientific research. That's why for us, the main topic was only to study how it works. After that, we took only, how can I say, bright examples, like bright examples, Yabloya, Kharkiv, Mykola, Olesia. But I think for our further research, we can make a few narrow database, and maybe,
Yes,
for
it's
example, from
more interesting. Yes.
yeah, because the first one, this is in general, but after that, maybe from Wikipedia, we can only concentrate, for example, on the last names or first names or the city names or some kind of formal features. That's why just we did general training of the words and the general corpus, because for us, the most important was to create corpus from Wikipedia, and after that to train this corpus from Wikipedia.
Thank you very much. Thank you very much for interest and research and answer. Thank you. Now we have next presentation. Very interesting tool, usage of sentiment analysis to tracking public opinion. Dina Kholieeva, yeah? Or going to show?
Yes, it's Zoia. I'm trying to show the demonstration.
So, we can see and hear you, please.
So is it visible? Because
yes, we can see.
So we can see. So good afternoon, dear colleagues. My name is Dina Huliieva. My colleagues Natalia, Borysova, Zoia, Kochuieva, Karina, Melnyk, and I would like to present our research usage of sentiment analysis to tracking public opinion. The problem of public opinion analysis, especially its sentiment analysis, today actual and falls within the interests of many organizations, companies, governments. Sentiment analysis can determine the emotional attitude of the author of the statement to any entity or to its properties, signs, parts, etc. It's not possible to do such analysis manually because of the following reasons. The first one is that the public opinion can change quickly. The second is that nowadays people can express their opinions via internet, so the number of statements which reflect the public opinion grows every day. Therefore, there is a real need to automate the process of sentiment analysis of public opinion. So our research focuses on this purpose. So the object of our study is the process of tracking public opinion. The subject is the theoretical and methodological tool for solving the task of sentiment analysis of public opinion. And the purpose of this work is to develop the sentiment analyzer of public opinion for Ukrainian language text. To achieve the goal, it is necessary to solve the following tasks. They are shown on the slide. First, I would like to draw your attention to an overview of existing methods and tools of sentiment analysis. All methods of automated sentiment analysis can be divided into the following groups. The first one is rule-based methods. The second is lexicon-based methods. The third is supervised machine learning methods. The fourth, unsupervised machine learning methods, and hybrid methods. All these methods have advantages and disadvantages, and I would like to know that in our study it is proposed to conduct the sentiment analysis using the lexicon-based method. In addition, the analytical review of software for sentiment analysis was conducted. These software are based on different approaches for solving the problem and can be used in different conditions. The list of modern actively promoted software is presented on this slide. The analysis has shown that all considered software are multifunctional, but only 2 of them support the Ukrainian language. Other products allow downloading own models for sentiment analysis and/or dictionary of sentiment words. But this service is paid, or developers have set restrictions on the use of the models and the user dictionaries. Thus, the development of its own sentiment analyzer of public opinion for Ukrainian language text is an urgent task. Let's consider the process of tracking public opinion based on using of sentiment analysis in more details. This slide presents the business process model in the form of BPMN diagram, and to start working with the sentiment analyzer, the user has to add a news item. Then administrator or other user has to add comments with defined category for this news. There are 3 categories of commands that correspond to 3 groups of people who are public speakers: the opinion of the media, the opinions of authors of articles in various online publications about particular news, the opinion of people, the opinions of ordinary citizens about news, and the opinion of experts, the opinions of people who are the experts in domain related with given news. Next step is the tokenization and lemmatization for each command. This stage of analysis allows comparing the found words with the words available in the sentiment dictionary. If the word presents in the dictionary, its weight coefficient is taken for calculations. The tonality of each command further is calculated according to the model of determining the tonality of the news. The next step leads for calculation of the tonality of the comments with particular category. The purpose of this step is determination of the attitude of different public opinion leaders to each news item. And finally, classify, estimate the overall tonality for each news item. It means the general tonality of public opinion about the news. To assess the efficiency of the work of the sentiment analyzer according to the standard metrics recall and precision, it is necessary to ask the tonality of all commands from experts of considered domain area. It was proposed in our research the using of the lexicon-based method of sentiment analysis. The main idea of this method is to use the tonal dictionaries where each word has a certain weight coefficient or several weight coefficients. The calculations of the overall tonality of the whole text is based on the weight coefficients of the words from the dictionary. And the dictionary of word tonality has been made for developed sentiment analyzer. Calculations of the tonality of the text have been carried out according to the methodology by Jurek, Malvena, and Bayer that demonstrates the determining the tonality of the news for English language text. This methodology was adopted, modified, and used for Ukrainian language text. The process of estimation of tonality of news is shown on this slide in the form of the activity diagram using the activity element defining the tone of the case command. The whole functionalities of the developed sentiment analyzer for different categories of users are presented in the form of a use case diagram. There are three roles of user: administrator, user, and expert. The administrator can add and delete news, commands, command categories, and user accounts, as well as view the tonality of comments and use and the results evaluating the effectiveness of the sentiment analyzer. The user has the ability to add news and command them, view all the sentiment assessment results and the effectiveness assessment results. The expert has the ability to manually set own assessment of the sentiment of comments and view the results of assessing the effectiveness of the program. All data and results of the sentiment analyzer work are stored in the database. Database model is presented on the slide. According to the aforementioned information, the standard metrics precision and recall have been used to evaluate the efficiency of the sentiment analyzer. And according to the results of calculation, the following metric values have been obtained. Precision is 0.861 and recall 0.849. Moreover, the value of the precision metric within the class has ranged from 0.807 to 0.921, and the recall metric from 0.775 to 0.930. Such results indicate that the sentiment analyzer works adequately in general and within each tonality class as well. The obtained values of metrics precision and recall of the lexicon-based classifier have been compared with the values of such metrics for two other classifiers, naive Bayesian classifier and Iryna-Smith classifier, based on a recurrent neural network, and the results for naive Bayesian classifier and Iryna-Smith classifier were taken from work where a similar problem was solved. All results of classifiers efficiency evaluation are presented in the table 1. And the authors of above-mentioned work describe an experiment where additional training of classifiers on slang corpus, which the tonality of slang words have been marked up, allowed to increase the efficiency of classifiers by 10–11%. And therefore, based on this information, we decided to supplement our dictionary with slang words and re-examine the work of the developed lexicon-based sentiment analyzer. And the results of metric calculation for the same three classifiers are presented in the table number 2. Comparing the results of calculations of metrics from the table number 1 and number 2, the increase of the efficiency of the work of the lexicon-based classifier hasn't happened by 10–11%. The increase has occurred by 5–6%. And this can be explained by the fact that not every of the analyzed commands contains slang words, and they are used only in the comments that the opinion of the people reflect. So in this study, all the tasks were solved and the goal was achieved. Thank you for your attention.
Any questions?
Yes, I have questions. May I ask?
Oh, of course, ma'am.
Good afternoon. Thank you for your report. I would ask why did you choose exactly these authors?
So we have chosen these authors because they are indulged in the problematic sphere, and they have their modern research, and it's based on new approaches and in new techniques. And of course, they have a lot of precise estimation, and their methodology is very effective and rather interesting for students and researchers in general. And of course, because their research is based on tweets, and of course, the tweets are shorter and they are emotionally more expressed, and it is actual field, and of course, it is easier to work with vocabulary with such tweets and with such items. That's why we took these authors.
Okay, thank you.
Thank you. Other questions? No. Dina, thank you very much. And we are going to watch next presentation by Olesia Barkovska and the team of courses, big team, information objects storage model with accelerated text processing methods. Please. I saw Olesia. Yes, I see.
Good afternoon.
Oh, sorry. Others
Yes,
also, please.
I'm presenting. Yes. Can you see me?
Yes, yes, we see.
Oh.
Take care. Please.
Good afternoon. My name is Vladyslav Kholiev. Today I represent Kharkiv National University of Radio Electronics. My presentation is devoted to one of the possible approaches to accelerate terms weight ordering in the frequency dictionary. And the title, as you can see, is Information Object Storage Model with Accelerated Text Processing Methods. The content of my presentation can be expressed in the following points. It starts from the introduction, including motivation, analysis of related works and main goals. Then I propose the organization model of scientific work electronic storage, as well as main steps of text processing on the information accumulation stage of the model. Then the focus will be on the assessment of the frequency dictionary sorting time in serial and parallel implementation. Lastly, the presentation ends with conclusion. There exists the problem of constant increase of information, the amount of information, which in turn leads to the increase of speed requirements of search engines and information categorizing systems, which are based on some of the methods presented on the slide. It also leads to the ever-increasing complexity of information object storage organization at the stage of information accumulation and the access to that information. The slide shows that methods such as text vectorization are significant in different areas and different tasks, which determines the high relevance of the analysis and improvement of these methods. Thus, the representation of texts in the form of vectors can be considered one of the main steps of text preprocessing, because it allows to consider a text not as a set of tokens or symbols, but in a more computer-friendly way, in the form of the vector. This approach is a basic tool in the field of text mining, information retrieval, classification, and clustering of text documents. Modern research papers confirm the relevance of the text proximity detection problem, which is also based on the text vectorization, and the construction of frequency dictionary due to the widespread use of this task in the plagiarism detection, determining document authorship, information retrieval, machine translation, texts and tasks creation, automatic construction of text abstracts, etc. Also, many researchers confirm the effectiveness of use of the TF-IDF model for determining term weights in the text summarization and sentence similarity tasks on the base of the word frequency and inverse document frequency. Among the most significant practical solutions connected with the information object storing and processing are electronic libraries, plagiarism detection services, electronic vocabularies, biometrical systems, and so on. The aim of the work is to create an information object storage model with accelerated text and processing methods. In order to attain the aforementioned aim, it is necessary to complete the tasks that are presented on the slide. To provide fast and relevant access to the information object, the organizational model of electronic I/O storage was proposed. You can currently see it on the slide. As shown, it can be divided into two stages: information accumulation stage and information access stage. The operation of each stage consists of operation of individual algorithms. The proposed model consists of the following modules: search query preprocessing module, information image search module, module for searching the keyword in the corpus, and finally database creation module. The input of the model receives a large number of documents in different formats such as TXT, doc, PDF, etc. Then the model selects a code library depending on the format of the source document and extracts the data, namely keywords, from the document in the form of text. The selected keywords are then used as input values at the stage of classification and catalog construction. An important stage of the algorithm is filtering the text through the stop words lists, which are short words and punctuation marks that do not carry any semantic load for further analysis. This reduces the volume of the text and increases its overall semantic value. The most important problem at the stage of catalog formation is the categorization of new documents with high accuracy. It is a complex task with great number of preprocessing steps, which all have a great influence on the categorization accuracy. The sequence of preprocessing methods includes different levels of analysis: graphian level, morphological level, and lastly syntactic level. You can see on the slide the results of such text preprocessing algorithm. The paper also proposes documents classification based on the frequency dictionary, the input of which is the aforementioned preprocessed text. To build the frequency dictionary, it is necessary to determine the IDF measure. By default, the result of TF-IDF model is a constructed dictionary with the weights of each word. The key in this case will be the words that have an IDF measure in the middle range of values. The time to construct an ordered frequency dictionary depends on the size of the collection. Arranging the IDF values of a large number of terms is a time-consuming operation, because the sequential algorithm is used by default. The paper conducts an experimental study on the effect of using different sorting algorithms for word selection time in accordance to the sorted IDF values. The results of keyword selection for different sized collection with standard sorting of IDF values are currently shown on the slide. As the table shows, the sorting time of the defined terms for large dictionaries is more than 8% of the time, which is why reducing the sorting time can provide good results. And here are shown the results of keyword selection for different sized collections with parallel sorting of IDF values based on the quicksort algorithm. The implementation was deployed on a system with shared memory and multi-threading platform using OpenMP. The results table shows that the proposed sorting reduces the operating time of the synthetic level block of the proposed model, but still takes a significant time. It is apparent that for small amounts of data, acceleration is almost absent. For large amounts, however, the acceleration is almost 3 times. The results of keyword selection for different collection sizes with parallel sorting of IDF values based on the least significant digit algorithm and radix sort are currently shown on the table. The implementation was deployed on a system with mass parallelism. As we can see, the radix performs poorly on small sets with less than a couple hundreds of elements. and that it is the preferred sorting algorithm for high-speed application for use in systems with mass parallelism, such as GPUs. The computing resources of NVIDIA GeForce GT 650 graphic processor with Kepler architecture and the maximum number of 384 CUDA cores were used for the calculations.
I'm
Analyzing-
sorry, you should go to finish. You should over. We have no time. Maybe next couple.
Okay,
Thank you.
in conclusion, the course of the research, the information store object storage model was, with modified and improved methods of accelerated text, was proposed. The detailed conclusions are currently shown on the slide, and the further potential development will include developing the proposed model and expanding the functionality. Thank you very much for your attention.
Thank you very much for your presentation. Maybe short question, maybe not. Thank you. Now we have a little time for next presentation, and then I propose to reconnect in the middle after this Zoom meeting will be closed. And then immediately reconnect, and we have possibility to hear last presentation of our schedule of our program. And then I ask the next speaker, and I see you, please, Mikola. Yes. We can't hear you. We don't hear you. You should turn on your microphone, unmute. You should turn on your microphone.
Yeah,
Yes.
this time better.
Please.
This is team from two organizations, from research and from the National Taras Shevchenko University. And we tried to move forward punctuation restoration in text, which are received basically from ASR as a speech recognition response. Why it's good motivation for this work? Well, if you imagine text without any punctuation, it would be terrible. So it facilitates further processing by human and for our other automatical techniques as well. What techniques? I mean, it maybe semantic parsing, question answering, machine translation, sentiment analysis, and so on. Well, so in this work, we selected the proper tool, proper parameters, and evaluated this on a small data set that could be available for community easily. And then I'll present the results on the real ASR system. So actually we consider punctuation in the first, its meaning as a system of graphic punctuation marks, and no way like other two meanings of this term. So we understood that syntactic morphological principles for punctuations could be modeled with only text presentation, and some other principles like semantic intonation principles for punctuation could be modeled much better if we would introduce some prosody information together with text. So the toolkit selected is Punctuator 2, based on bidirectional LSTM with intention mechanism, and we make a good choice, as we believe from our experimental research, which consisted of 3 stages. Firstly, we evaluated the baseline model with very basic text processing. Then on the next stage, some more sophisticated text processing was applied. And on the last stage, we tried to introduce, to integrate to the system some word embeddings. So we evaluated our work on Brown UK database, accomplish it with some text from the public domain. It's really not so large database. From another side, it's verified, and we can guarantee that all punctuations and all words are correct in correct positions and with very small errors and typos. So 11 models were trained and evaluated, and we found that best result was achieved on LexVec word embeddings. As next step, we try to look how we can benefit with punctuation restoration in our ASR system. So actually, we implemented punctuation in the post processor, when we have some sequences of words and nothing more. And our post processor receives such an information like you see on the screen, just words after words. And after the punctuation restoration, from a human point of view, we receive the text more pleasant for an eye, and much easier to perceptible by human. And of course, there are still lots of mistakes. You know, there are many obstacles to receive the ideal punctuations. One of the reasons is that it's a spontaneous speech, and punctuation is more or less is conditional. So we limited in only 3 punctuation marks. It's period, comma, and question mark. So on these 3 slides, you can see some examples of errors. We conclude that some errors are maybe crucial, maybe frustrating for speaker, and in some cases the recognition result may cause the incorrect punctuation, and in some cases punctuation restoration is robust even to small, not so big ASR errors. So still in many cases punctuation is helpful, and this system is in use by broadcast monitoring company. So we plan to continue in this direction, trying to reduce dictionary, integrate prosody features. You know that multilingual case is very topical for speech signal. From other side, we concluded that speaker diarization, when we know when one speaker started its turn, it's could be beneficial, and some other sophisticated embeddings, language model